Welcome to AP Calculus. AB. Da-da-da.
All right, so one of the things that we talked about in 4.3 were how to find maximums and minimums, right? How do you find, if you have a function, how do you find where it has a maximum and a minimum, Brittany?
So you do the derivative, and then you set it equal to 0, and then you try the CP equals, and
Right.
then you test it on the number line.
Perfect. So you take the derivative of whatever your function is, right? So you have some function, you find the derivative, you find where it's equal to 0 or undefined. Those are your critical points. And then let's say you have critical points and it goes plus, minus, plus, so it goes up, down, up, right? So we can determine maximums and minimums. Now, if we have endpoints, those would also be considered maximum or minimums. So in this lesson, we are going to apply that process to optimization problems. Okay, so we want to maximize or minimize things. So the way, like for example, in the real world, maybe you want to create a box and you want to maximize the volume. So you want to fit as much as you can inside, but you want to minimize the surface area.
Good, that's my
Because
average thing.
you want to create. Right, if you're creating something as a company, you want to use the least amount of material, right? That you can maximize the volume. So what you need to do is first you need to come up with a function. And that's the hard part in this lesson. Because once you have the function, all the rest is what we've already done. Okay? So it's coming up with, so number one, understand the problem. Okay, we have to identify what information that we have on what we need to find. Then sometimes if it helps to draw a picture, sometimes it doesn't. Okay, label the parts that we know. And then this part is kind of optional, graphing the function. You can also consider the domain. Sometimes we have to think of this logically. It won't say the domain is from 0 to 10. You just have to think about, oh, what's the smallest value? If you're talking about the length of something, it has to be greater than 0. Right? And maybe there's a maximum length that we could have. Then here's the next part, find the critical points and endpoints, and then solve it and interpret the solution, okay? All right, so let's look at our first example. Now, some of these, this is gonna be a pretty easy one. You might be even thinking of this intuitively, but I wanna take you through the process because there are problems in the homework and problems on the test that you can't just figure out that way. So let's see, two numbers whose sum is 20 and whose product is as large as possible. So,
No,
Wait, hold on a
10
second.
and 10 is not two numbers, that's one number.
okay, again, so you guys think it's 10 and 10?
It's not, it's
Yeah.
9/11.
I think it
18
is,
and
but like it's not.
Oh my god!
No, it's 10.
10 and 10. It doesn't say two unique numbers.
Yeah, so it's 10 and
Okay,
10.
so let's go through, I'm gonna take you through the process though, because the problems aren't always this simple. So I'm gonna now, two numbers whose sum is 20. So I'm gonna say, all right, I have x plus y must equal 20, and I want the product to be as large as possible. Now, so we want to take x times y. Well, yeah, if it's as large as possible, we don't want any negatives.
What if they're both negative?
Negative 10 times negative 10 is.
Yeah, negative 10 plus
But
negative
negative
10 is
10
20.
Yeah.
Oh, yeah, right.
Okay. So we want to maximize this. The problem that we have when we work with optimization is we only want to have one variable. Okay, so right here, gonna introduce a variable. Now we have x and y, but we can rewrite one of them in terms of the other. So for example, if I have x is one of the numbers, then, so we'll say x is the first number, then y would be the second number. What would y be equal to?
20 minus
20 minus
Makes
x.
sense when you think about it.
No, it doesn't. What else?
Yeah, it does.
Okay.
Thank you for the commentary.
All right, so the reason I did that, I want to come up with an f of x. I want to come up with a function. Now, my function is what we want to maximize. We already said we want x times y, but of course we don't want to use y. We want to use 20 minus x. So I have x times 20 minus x. Are we good with that? Came up with our function. So now we're going to go through this process. Now, before we do that, right here, step 3, consider the domain. Okay, what's the small, basically from what to what could we possibly have here?
0 to 20.
0 to 20. And I'm going to put in, well, actually we can inclusive.
I mean, but it's obviously not going to be 0.
It's obviously not going to be 0 and it's not going to be 20, but we will include the endpoints. Yeah, what's that, Jacob?
Can't be any number lines?
Because they have to add up. to
No,
20.
so
Oh, I mean, you can do 21 plus.
Yeah,
But
but
then
then
it would
the
be-
product will be
Okay,
negative.
but what I'm saying is, I know it's not big. but
Right.
You can still have.
So this is the part where you have to think logically about our domain. We don't want to have negative numbers. So like -1 and 21 add up to 20. I mean, I guess you could, but the product is as large as possible. If we include any negative numbers, it's not gonna,
Right,
it's
I
just
know
not gonna
that,
make
but-
sense. Yeah, I guess
Still
you
the
could.
domain.
Well, I mean, the function that is the domain of the actual function is all real numbers, but like.
Which is what we're going to find out later. So the next problem where we have a box, if you think about the actual function, yeah, it's going to be all real numbers. But from a logical standpoint, you can't have a length of something being negative.
So we do it more
Up
necessarily
billion.
logical, not.
Yeah, because these are real, these we consider our real world problems.
Good.
So,
I would have really loved
We
to
have to
make
think
you
about
box
this.
out there.
So it's not just the domain of the function, it's the domain right here. Determine what values the variable that makes sense in the problem. So when we're considering our domain, it's not just the function provided, it's the actual problem that we're working with, okay? So now, before we do the derivative, because I don't want to do product rule, we'll just multiply that out. So we have 20x minus x squared. So what do we get for our derivative?
20 minus 2x.
So we set that equal to 0, and we do get 10. So our answer is going to be 10 and 10. Now, you don't have to do the number line part, but if you wanted to confirm,
How does that make sense with 10 and 10? Shouldn't it be x plus x equals 20 then? Shouldn't x and y be different numbers?
X
We're not doing x
and then
percent.
20 minus 10.
What's
is
y equal
also
to?
10.
10. You said it's 10 and 10.
The second number is 20 minus x.
20 minus 10 is 10.
I know, it just, why are we using two different variables if they're the same number?
Because we don't know that going in.
you don't know that until you solve the problem. Now, many of us, before we even started the problem, we thought, oh, 10 and 10 makes sense. So I wanted to take you through the process of solving it, because what if I didn't use two numbers whose sum is 20? What if I said the square root of one number or the square root of a number and itself, right? You get more complicated problems.
We gotta have stuff like that.
So, on the homework.
I say,
Okay, so just to confirm on a number line, so if I were to plug in, let's say, 5, I'll get a positive. And then if I plug in, say, 15,
You should get a negative.
so it goes up, down. So we can confirm. Remember, we were looking for something as large as possible. So that means by plugging in 10, I am going to have a maximum there. Now,
That's cool.
what you'll find out is almost always when you find your critical points, those are usually going to be your maximum or minimums, but sometimes it could occur at the end point. So that's why, just to confirm with a little number line, just takes takes less than a minute to do. Okay, are we good? Questions? Okay, example 2. We have an open top box. We want to make this. So starting with a 10 by 16. So imagine that this originally was like this. And this was 10 and this is 16 inches. And we're going to bend up, we're going to cut off the squares on the corners and bend up the sides to create an open top box.
Okay, I don't buy this. The 16 is like 3 times as long as the 10. Or at least twice as long.
Okay, he's not drawing the scale.
I'm just saying.
Okay?
It doesn't say that.
All right, how large should
No
the
one else is not on the scale?
how large should the squares be?
Shut up.
How large should the squares be to make the box hold as much as possible? That means we're trying to maximize. So we want to make the squares so that we have a maximum volume.
This is abusive to the rights of function.
Does that make
I
sense?
mean, how little do we cover?
We want to figure out what x is, or like what that, let's say this is x and this is x. So we want to find x so that volume is maximized.
No, because that's gonna be it's gonna be a box this tall,
Yeah,
and you barely have anything in it.
right. So you don't want the squares necessarily to be as small as possible. You want the volume to be as big as
You want them
possible.
to be as big
So
as
we
possible.
don't know what x is going to be. We want to make sure. Now, volume is, in this case,
Is this actually how they make boxes? I feel like this isn't.
this is length times width times height, okay? So we want the product of those 3 things to be as big as possible. So if we made the height really, really, really small, that's going to make our volume really, really small. Like you can make a really big box, right, with a very large base and then a tiny height to it, and that's not going to give us that's not going to give us a big enough volume. We want all 3 multiplied together to give us the biggest number. Okay, so what we want to do is we want to come up with, now remember in the last problem, I said we only want to have one variable to work with. That one variable is going to relate back to that side, the x times x, basically. So what we want to do is we want to figure out what would be the length, the width, and the height in terms of x. Yeah. So what am I doing? I'm cutting out x on 2 sides. So this is going to be, imagine from here to here, that's 10 minus 2x. And from here to here, I have 16 minus 2x. And of course, when I fold that up, remember these are all x's. So that's our, exactly. So v of x, so 10 minus 2x times 16 minus 2x times x. Does that make sense how we came up with the formula? Now, let's think about, before we go through and find our critical points, let's think about our domain logically, not according to the function, because again, this is a cubic function, so I know my domain can be from negative infinity to infinity for the function. However, realistically for the box,
5, it can't be bigger than 5.
can't be bigger than
Between
5.
5 and 8.
How about
No.
between 0 and 5? Why?
It's also that.
Because if it's 5, then the entire side of the width is cut off.
Okay, so we don't, I'm going to use parentheses this time because I definitely don't want 0, because that would make the whole volume 0, right? So it's got to be bigger than 0, but less than 5. Why does it have to be less than 5?
Because you can't have a negative.
Yeah, so we don't want to go, if this was 5, that would make this length 0, and therefore make the whole volume 0. So we want to make sure our answers stay between 0 and 5. The reason we do that is because sometimes we get critical points that aren't in our domain, so we just kind of exclude those.
But
Yes.
if it was exceptionally large, it would go back to being positive. It would,
All right.
It would become a negative times a negative, and thus become exceptionally
Shut
large.
up, Ryan.
So volume,
I'm actually curious whether
boxes
this is wrong.
negative, they don't make sense. Just trust me, 0 to 5, let's move on. So before we multiply this out, I don't want to have to deal with the product rule necessarily, so let's maybe FOIL and multiply by x, and then we'll just do the power rule. All right, so here we get, go ahead and just, you guys multiply that out.
4x cubed, 4x squared.
Minus 20x squared minus 32x squared plus
Wait, what?
Okay, can you put it in, can you give it to me in order from largest degree to smallest?
4x squared.
No, 4x cubed.
Oh, that's after you
Oh, I
multiply
forgot
out
about
minus
the cube.
52x squared plus
Minus
162.
32x squared
64x.
It's 50.
minus 32x.
Oh, wait, no, I thought it
What?
was.
No, it's
Because
52.
10 times negative 2
Because
and
you
16 times
distribute.
negative 2.
Oh, I didn't add
Plus
that. Wait, I didn't add
160.
that. I didn't add that.
Distributive property.
Okay.
Buddy.
All right, so my first derivative is going to be 12x squared minus 104x plus 160. Now, at this point, we have a quadratic,
Can you take out the
so we can, see if this is going to factor. What goes into everything? Not
4?
4 goes into everything?
Yeah.
And I'm left with 3x squared. What's that? 12 doesn't, because 4 goes into 104.
26.
Yeah, 26.
25 is 100.
Plus
40.
Okay, so I'm going to set this equal to 0. The 4 we can pretty much ignore right now. Are we okay with that?
So it has to be 3 and 1. $20 and 2, but you did the 2 with the 6. The 2 with the 3 to make it 6, and the 20 alone.
Yeah, it's
Negative
22.
20 and negative
Yeah,
30.
that's it.
22.
Minus 20 here,
Oh, nice, bro.
and minus 2 here.
So 20 over 3 and
That
2.
works. Yeah, so when we solve our critical points, we get 20 over 3 and 2.
And is that just the answer? Or
No, okay, so wait, we
Oh,
have
because
to
we
first
have to do
consider.
No,
not the
the 20 over 3 wouldn't work.
Exactly, so 20 over 3, one of the reasons I had you consider the domain in the beginning, before we did all that, was so that we didn't mistake 20 over 3 for one of our critical points. That's not in the domain. So now we just have x equals 2. Now, what does x represent?
it's gotta be
That's the size of the squares. Now, let's just confirm that. Oops. Let's confirm on a number line just to make sure. So here we have 0, 2, and 5, and this is v prime.
It's gonna be positive.
So, yeah, if I just look at v prime, yeah, it definitely has to be what? Plus and then minus?
No, it's.
What's wrong?
No, it's positive from 2 to 5. Yeah, right. If you. Oh, you plug it into
No.
you plug it into the derivative?
No, wait.
Okay, never mind.
Where I thought it was.
No, if you
No, that's negative.
It's negative.
Yeah.
Right, we always plug into the derivative. Remember, when we make our number line, it's the derivative.
Zero is not the derivative.
This part here, oh, this is just this.
Oh.
I just didn't.
But Miss Casey.
Okay, so now we have 2 questions asked here. Just a minute. How large should the squares be? The squares should be 2 inch by 2 inch. And what is the maximum volume? So the volume is V of 2, right? So it's probably easiest just to plug in here, but just whatever, use a calculator if you need to. It's what? 6 times 12 times 2? 144. And that's cubic inches.
And I have perhaps an irritating question.
Okay.
But if you go back to the original,
All your questions?
mostly, if you go back to v of x and you plug in for say 15, you'll get a larger number.
But 15, that would not be a possible measure. If you have a piece of tin and you're saying, oh, I'm gonna cut out 15 square inches out of a 10 by 16,
Yeah.
it doesn't make any
It's
sense.
got like a slanted box.
That's why I keep going back to when we're considering the domain, we don't just consider the polynomial.
It'd be air.
Does that make sense? We consider the actual problem.
You'd be like cutting a
Okay.
square in like the floor.
Let's take a look at the next one. So we are now designing an oil can. Okay.
As you do.
Can
Here
we write
is-
like cool stuff?
okay.
Can we draw it?
What dimensions? So in other words, we've got to find the radius and the height. We'll use the least material.
Okay, and it tells you it's,
Now the
1,000
volume
square meters.
is pi r squared.
I designed it.
Got pi r squared times the height is the volume, and the surface area is 2 pi r h plus 2 pi r squared. Most of the time, the formulas are provided. Every once in a while, they don't provide. These would be like your free response type questions. Usually they give you the formula. Every once in a while they don't. So it's definitely something that we'll review. Now, what are we trying to minimize? The volume or the surface area? Surface area. So we want to minimize the surface area. Now the problem, remember, anytime we do these maximize or minimize problems, we only want to have one variable. But I look at this equation and I have two variables. I have radius and the height. Okay, so what I need to do is I either need to write the height in terms of the radius or the radius in terms of the height. How do we get there? By using the volume. Notice we were provided the volume was 1,000 cubic centimeters.
That's not the.
So, okay, volume is 1,000 cubic centimeters. And we know the volume formula, pi r squared times the height is 1,000. Now, it really does not matter which one we solve for. Usually I would pick the one that would be easier to isolate.
So, shouldn't you just do?
Because you see, if you just try to solve for r, you're going to end up with a square root, which is fine. I mean, we have a way to find the derivatives of those with a square root, but it's probably easier to solve for h. Would you agree?
Yes.
So I'm going to just divide both sides by pi r squared. So I have h is 1,000 over pi r squared. So now we're going to substitute that back in so that I can now minimize that surface area. We good? So we have S, and this is going to become S of R. So 2 pi R 1,000 over pi r squared plus 2 pi r squared. Now I'd probably simplify that before we try to do the derivative, right? So that would be what, 2,000 r to the negative 1?
What?
Wait, that's.
Yeah.
I agree.
Eh?
Yes. Yeah.
What's wrong?
Use
Yeah,
the
sure.
chain.
Why not?
What just happened? Why?
It's
what?
pi r squared to the negative 1 in that case.
Why to the,
You did a plus on the y.
No, it's negative. It's a,
Whoa, what?
isn't it just 2,000 r to the negative?
That's what I said.
Yeah.
I haven't done the derivative yet, guys.
Oh, you know. Then what's 2? Oh, 2. Oh, okay. My bad.
Got it. Now you see, I haven't done any derivatives. So I always try to simplify before we do the derivative. Just like when we had the volume, it was easier to multiply it all out rather than try to do that product rule a couple times.
Where's the -1 from?
Well, because I have R and then R squared on the bottom, so that would be an R in the bottom. You don't have to do it that way. You're right, 2,000 over R. So now we'll do our S prime of R. So that'll be negative 2,000. R to the negative 2, so I'll just put that R squared, plus 4 pi R.
Oh,
No, yeah, I said it, and then I just put the squared. There we go.
What happened to the pot? Oh.
So now we want to find the critical points, and I totally forgot to consider our domain here, but what would the domain here is a little bit,
Isn't it parentheses from 0 to infinity?
No, because it can't be.
Oh, no, it can't be infinity.
You can't make it.
it can't be infinity,
Wait,
but
do we have to take into consideration the pi?
So
So wouldn't it be 0 to 3.14?
so it would be, no, because remember 1,000?
It can't be 1,000. It has to be like significantly
So-
less than 1,000. No, but it has to be.
No, it has to be 0 to 10, doesn't it? 0 to 10, because 10 times 10 times 10.
Yeah, I'm kind of with you.
Pencil.
But the height can be any
Actually, that's
Can
true.
the height be anything?
anything.
It could be 1.
So divide by pi, and then take the square root of that.
Wait, divide 4 pi.
So,
Because we're solving for R,
Can you do 2,000?
18.35.
25. Actually 26.
Okay,
And how do we get that again?
so consider the radius. If the volume is 1,000, so if we divide by pi, and then take the square root, it can't be any bigger than this.
How do we know the square root and not cube root?
Well, because it's pi r squared.
Oh.
And so it's making sure the radius is
Yeah.
positive.
Exactly. So now we want to set this equal to 0. I'm running out of room. Okay, so what do we have? 4 pi r cubed equals 2,000.
What? Oh, okay, I understand.
Not really.
I just sometimes.
Okay, and now we're gonna. I didn't think I did any kind of special magic. I literally like. Cross multiply.
You guys ever watched
I
that?
know
That was
that's-
math
if you
magic.
draw this multiply, that's
In this case, it's like.
You guys ever see that thing, Math Magicians, when you were in elementary school?
No.
Have you ever seen that thing on Mr. Duke's Math?
Okay, let's continue. So r is equal to the cube root of 500 over pi. That's kind of a messy looking answer. So let's make it into a decimal to 3
That
places.
would be cleaner.
Well,
That sounds worse.
when you look at cube root of 500 over pi, could you approximate that? So there are times where a decimal approximation is better.
50.
I would say it's about 5.419260701. I don't know. I guess.
1, 3, it's cube root, what's, so it's about
Throw in number.
4 would be
5 point to 3 places, what is it?
419.
419. Okay, so going back to the problem, what are the dimensions? It says find the radius and the height that will use the least material. So we have our radius. What does the height have to
You have
be?
to plug it back into the 1,000.
Yeah, so go ahead and do that. So radius,
5.419.
Well, you can just plug it into the volume equation. Right?
Why would you do
Why would you do that if you already have like H equals?
okay, go ahead and do that.
Simpler. What? That's no. No.
Okay, let's say double cylinder. It has to be exactly twice as long. It can't be yeah, this is
You get it.
Anyone
I
wanna
got
do the math?
10.839.
not this tall.
Everyone else?
10.839?
10.8.
I got whatever you got.
I checked.
Well, don't trust me. You know how often I get these wrong?
Tomer, did you
Oh,
figure it
just
out?
Multiply by 2, is that it?
Here,
No.
just do 1,000 divided by pi times this squared.
Or you could just do
Multiply by
5.4.
two.
I don't have my
That's
answer key in
not
front of me,
always
so I don't,
Multiply by
and I don't have my calculator out.
This time it is.
See, I told you, it's just double.
This
Should I
time
just
just
do it?
multiply by
It
2.
It is.
That literally means nothing.
Did anyone?
It would actually be 10.840.
See, I told you.
So it's not multiply by 2.
No, it's squared.
You can truncate or round.
8395.
5 squared is
But-
not 10.
Okay.
But what I'm saying is 839 is acceptable for an answer. Is you can truncate, we talked about that, just
And on
stop
the
it at
AP
3
test,
places
too.
or round, so both would be acceptable.
On the AP test also truncate.
Okay, yeah, that's fine. So let's say we have a rectangle is to be inscribed under one arc of the sine curve. So we want to figure out the largest area that that rectangle can have. Okay. So we're trying to figure out the dimensions, oops, here and here. Now, this is the sine curve. In other words, this is y equals sine of, we'll say sine of x. Now, what does x correspond to? That actually is the same. You'll see here. You see how this is the same height here and here? It's symmetrical. We're going to say this is a length of x.
Wouldn't the whole thing be linked?
Why isn't that
Wait,
cosine?
why is that x?
Okay, hold on. You understand the whole curve itself is the sine curve.
Yeah.
What is the height based on? It's based on where the x coordinate would be. Okay. So we would say this is a distance of x, right?
That makes sense.
Which makes this also a distance of x. But that doesn't give us the base of our rectangle. So now let's think about from here to here. Where does sine cross?
Is it a pi over 2?
So this is 0.
Yeah, no, it's pi.
But what's this point on the x-axis?
Pi.
No,
Where does it cross again? When
Isn't
is
it pi
sine
over
0?
It says 0.
That's
It's
pi
not
over
pi
2.
over 2.
It's
Pi
not.
over two.
Yeah,
also
it says it right
that the
there.
range is
0 to pi. I know, but I'm just saying, like, we know for sure, other than based just on the window, we know that sine crosses at 0 and pi. So
I knew that.
knowing this, what would represent the length of the base?
Pi.
Pi minus,
2x.
perfect. Okay.
Oh.
All right, now, we want to find the largest area. So area is base times height. So we now know our base is pi minus 2x. What is the height? What's y?
1.
No, what's our?
No, isn't it sin x?
It's sine x. Remember, here's the thing. We don't know where the rectangle is going to be.
Oh, 'cause
It's going to be
coordinate
based on this, but our height, the height is always represented by the curve. Whenever we have these types of situations where we have something that's being enclosed, the height is always determined by the y equals. Okay, so just keep that in mind. Now, we don't know where the rectangle is going to be. We don't know how big it's going to be. That's why we have to go through this process of finding the largest area. Now, what could our domain be?
0 to pi. 0 to 2 pi.
0 to pi.
Or 0 to pi.
0 to pi over 2?
Yes.
That also.
Not inclusive because we don't want it to be 0.
Okay.
So let's go through. Now, we could multiply that out, but it doesn't matter. We're still going to end up having to do the product rule. So I'm just going to go right to the derivative, which will be what?
Wait, are we doing the product rule?
I'm doing the product rule. So I'm making pi minus 2xu, sine x is my v.
Can't the domain
So negative 2.
Can't the domain be from 0 to pi? Because sine of pi is still 0.
hold that thought. Okay, this cannot be solved by hand. So we're going to plug this into our calculators. Yeah. So we have to set that equal to 0. In other words, plug this whole thing into y1 and look for the 0. Where does the 0 have to be between? 0 and pi over 2. So why don't we want to go beyond pi over 2? That's what you were asking.
Yeah.
Why don't we want to go beyond pi over 2? What's the base have to be? Pi minus 2x. So if we made that bigger than pi over 2, that would make this a negative length.
So you check the zeros? Check
Yeah,
the
find the
zeros.
zeros. Solve on calculator by finding the 0.
9, 4, 8.
Make sure you're in radians. Well, what I would
Oh
do,
my god, it's pi. What?
I don't think that's like.
Told you.
What do you do though?
I got
what
pi.
do you do to put that?
Stop
I
it.
don't understand. You put it into y equals?
You didn't graph it. I didn't need to graph it. It's
Didn't have to.
oh my goodness, -2 sine.
Hold on. You have to come back later. Whoa. Sorry.
The non-labs maybe too hard sometimes.
Okay.
You just don't laugh hard enough.
Don would be a great evil villain.
No,
Alright.
he wouldn't.
No, just because.
Like an evil villain on
I mean,
Sesame
he's
Street.
already-
but
No,
not
yeah.
like
No, like in like a really corny like kids movie.
No, you're in the.
Fall into
It's pi.
like the guy from Master this guy.
It's actually decent. It's actually pretty good.
Oh, whoops. I messed up here.
I got 0.71.
That's what I got. I got that too, Reagan.
Yeah, that should be right.
What did you also get this?
I too got that.
Yeah, but
I
you have
was
to remember that the
also
domain is from
in
0 to pi over 2.
the rightness.
That's fine.
Right, so, okay, I graphed it. I got 2 places, but
Shit, it's pi.
this is too big because this goes beyond pi over 2. So we want this 0, and what did you guys say you got?
0.71.
0.71.
0.
Yeah,
0.
You're just wrong.
Okay.
The origin.
So what are the rectangle dimensions?
0.710 times pi minus 2 times 0.710.
And the area? So, yeah, just do sine of 0.710. Point 651. So did we get that? 0.651. What did we get for our area? You could also just multiply those.
You know about 0.651?
What's the height? The height is sine x.
Oh, the height sine. Okay.
And that you could just multiply those two together because it's base and height. What do we get for the area?
That's such disappointment. Such sadness. And it's all 0.4621.
Sorry.
What is it?
0.4221.
Oops.
I got 1.12.
Oh,
I got that.
Reagan is wrong.
No. Don't you have to do pi minus 2x?
Times sine of.
Yeah, you just did 0.71.
That's
not.
oh, that's right. That's right. You know what? I'm sorry.
So we're not gonna go.
Sorry. The dimensions are pi minus 2 times that. That's right.
See, I did the
All right. So pi minus 2 times 0.71. There we go, 1.721.
Is y or x?
And now we multiply those two together. That makes more sense.
1.72.
So I obviously would have gotten this problem wrong like 6 times after this.
Okay, so multiply those two together, and that should make more sense.
I did it.
Or if you plug or if you just plug 0.710 in here, what do we get?
1.1186.
1.1. Okay. All right.